Question B1. This question is about the photoelectric effect. State what is meant by the photoelectric effect. Well, we know that this is the ejection of electrons from a metal surface due to the action of light on that metal surface, due to the electromagnetic waves falling on that surface, or photons falling on that surface. So in B, we have light of frequency 8.7 times 10 to the 14 hertz is incident, so it falls on the surface of a metal in a photocell. A photocell is like a small energy producer, electrical energy producer that is caused by light. The surface area of the metal is 9 times 10 to the negative 6 meters squared, and the intensity of the light is 1.1 times 10 to the minus 3 watts per meter squared. Deduce the maximum possible photoelectric current in the photocell. So we have the surface here, which has got an area of 9.0 times 10 to the negative 6 meters squared, and it has light shining on it, and this has an intensity of 1.1 times 10 to the negative 3 watts per meter squared. And we also have that the light frequency is 8.7 times 10 to the 14 hertz. Now, what we can do is we can work out the number of photons falling on the surface, and then we're going to assume, because it says maximum possible photoelectric current, we're going to assume that every photon causes one electron to eject. So that would be the maximum possible. And if we can work out number of electrons per unit time, we would have our current. So the first thing that we're going to do is we're going to work out the energy of one photon. So we're going to have h times our frequency. So in doing that, we're going to have 6.67 times 10 to the negative 34. That's your Planck's constant. It's found with all the other constants, times 8.7 times 10 to the negative 19. And that will give us, 8.7 times 10 to the 14 times 10 to the 14. And that's going to give us a total energy per photon of 5.8 times 10 to the negative 19 joules. So each photon has got that amount of energy. Now, how many photons are actually hitting the surface? Well, the intensity is 1.1 times 10 to the negative 3 joules per second per meter squared. So if I multiply this 1.1 times 10 to the negative 3 times by the surface area, 9 times 10 to the negative 6 meters squared, this is a joule per second here, per meter squared. So this is going to cancel out. I'm going to get an answer here which is joules per second. So if I multiply that times that, I'll get a joules per second. And if I divide by my 5.8 times 10 to the negative 19, which is the energy per photon, I will actually get a number of photons per second coming out. So if I do that or times that, or I get something like 1.7 times 10 to the 10 photons per second. Alright, so you've got that many photons per second. Now each photon we are going to assume causes the ejection of electrons, so therefore we're going to have 1.7 times 10 to the 10 electrons. Now each electron has got a charge of 1.6 times 10 to the negative 19, and this is going to be per second. So you're going to have a charge per second. Now remember that your current is equal to Q over T, the charge per time. So we'll get a charge per second, and we will get there when we do that. It works out to be about 2.7 nanoamps when we do that. The last question here we have, the maximum kinetic energy of the photoelectrons released from the metal surface is 1.2 eV. Calculate the value of the work function of the metal. Now, we know the energy coming in. So actually we're going to be using this formula. Actually, we can use this. Let's use this one over here. We have got that HF is equal to phi plus E max. So we've got that. Now our E max is equal to 1.2 eV. So I'm actually going to have to convert everything into eV. Now remember, we already calculated that the energy of one photon, the HF over here, was equal to 5.8 times 10 to the negative 19 joules, and I would have to multiply that times 1.6 times 10. Sorry, I wouldn't have to multiply it. I'd have to divide it, because when I'm going from joules to eV, I divide by 1.6 times 10 to the negative 19. So I'm going to divide that by that. Is equal to phi, which is your work function that we want to find out, plus your EV. Now your EV, your E max here is 1.2 EV. Now I think you can see when you cancel, this will cancel with that. We're going to get 5.8 divided by 1.6 minus 1.2, and your work function for that works out to be about 2.4 EV. If you had done this, put this into joules, you would have 2.4 times 1.6 times 10 to the negative 19, and you'll get your answer in joules, and that will equal your work function.